Welcome everyone. Today's lesson is entitled Fundamental Counting Principle. And my sense is actually that you have seen this principle before in some way, shape, or form with your previous math work. So my thought for this particular lesson is to just do a quick review of what the principle represents, what the context is for using it, and then just go over some examples relating to the counting principle, starting with an easy one and kind of working our way up in difficulty. So why don't we go ahead and get started here. A little introduction to counting. And really at the end of the day, when we talk about counting, we're talking about how many ways a particular outcome or series of outcomes can occur. And so I just came up with a bunch here just to get us going, thinking about it. And all it is just how many ways something can happen. And so letter A, how many possible 5-card poker hands are there? And start looking at some large numbers with this. So I've got 2,598,960. That's how many different 5-card poker hands there are. How many seating arrangements are possible with a class of 30 students in 30 desks? If you try this on your calculator, and we'll do stuff like this over the course of these next couple lessons, but this one has to be written in scientific notation as the number is significantly large. So 2.65 times 10 to the 32nd possibilities there. Powerball, how many different Powerball number combinations are there? So if you're looking to buy a ticket and you want to get the exact one, well, there are only 292,201,338 possibilities. That's all. Piece of cake. All right, so look, at the end of the day, as I said, it's just a matter of how many ways a series of tasks or a series of outcomes can occur. And the way we are going to do some of these problems comes from the fundamental, or sometimes called the multiplication, as you'll see why in just a sec, counting principle. And so it's a mathematical way to determine the number of ways that a series of events can occur. And so here's what I basically have, and I'd encourage you to write the same on yours. So if there are m ways to do one thing, or to form a particular task, or m possibilities for one task, and n ways to do another task or another thing, and then we'll get a conclusion momentarily here as soon as I write a little faster. So let me just read that one more time, make sure I've got it. If there are m ways to do one thing and n ways to do another thing, well, very simply, when we start talking about getting both of them done, then there are m times n, there's the multiplication, and that's why sometimes it's called the multiplication counting principle, ways to do both things. Okay. So if we know how many ways we can do one and we know how many ways to do the other, well, very simply, the number of ways to do both would be by multiplying the individual possibilities together. So again, I think you've worked on this before. Example 1 is just sort of a prototypical easy one to get us thinking about how this works, and then we'll formulate some more formalized ways to do this, and as the problems get a little more difficult, really think about how we want to set up our strategies here. Okay, but let me go ahead and read example 1 and get us going. So Josh has 4 shirts. I listed them, 3 pairs of pants, again listed, and 2 pairs of shoes, all good. How many ways can he select an outfit? All right, as I said, just contrived, very, very straightforward. So in order to create the outfit, he obviously has to pick a shirt, then he has to pick a pair of pants, and then he has to pick a pair of shoes. Sounds good. So the first task, so to speak, is picking a shirt. And so how many possibilities are there for that first task? And just to kind of start it out here, and I'll get a little better with this as we go through this, the first task is to think about the number of possibilities for picking a shirt, and of course there are 4. The next task would be to pick a pair of pants, And so I think about, well, how many possibilities are there as he performs this particular task? And it looks like there are 3 possibilities. So 2 individual tasks, one and then the other. And then the third one, obviously, to get the outfit together is picking a pair of shoes. How many possibilities are there? How many ways can he perform this particular task? And in this case, there are 2. And so if I have the number of possibilities for each individual task, what do I do to get the entire outfit together? Very simply, everybody, I multiply them through. So to create the outfit means he has to pick a shirt and pick a pair of pants and pick a pair of shoes. When I use the word and with counting, and we'll also see this in probability, by the way, but when I use the word and as I'm thinking things through, that means multiplication. Shirt and pants and shoes. Multiply the possibilities at each step, and of course, that gives us 24. So 24 outfits total, and sometimes, and I have a feeling when you potentially did this in some of your previous work, in one of your previous math classes, you maybe did like a big tree diagram and counted out all those possibilities to really see the how and the why with the multiplication counting principle. But for our purposes, as I said, I just don't feel like that's a necessity at this point. Okay, well, I'm going to move on to example 2 then. Again, just getting the idea of performing an individual task, how many possibilities are there, and then just continuing for the next task and the next task, et cetera, et cetera. So how many ways can 6 true-false questions be answered? All right, so the first task is to answer question 1. So I'm just going to do a Q1 underneath. Hope you don't mind. You don't have to do that if you don't want to. But that's the first task, right, is answer the first question. Well, how many possibilities are there for that first question? And there are 2. Excellent. And then I go on to the next task. Well, the next task is to answer question 2. And so I answer question 2. How many possibilities are there for question 2? Again, could be true, could be false, so there are 2 possibilities. What's my next task? To answer question 3. And so 2 possibilities there, and I'm hoping you're starting to see what's going on. Then I have to answer question 4, and there are 2 possibilities there. Getting closer, answer question 5. There are 2 possibilities for that. And lastly, I have to answer question 6, and there are 2 possibilities for that one. And so now what I've done at this stage is I figured out all of the possibilities for each individual task. Now if I want the number of total possibilities for this series of tasks, well, very simply, I multiply. So little multiplication right in between each, all good, and I get 2 to the 6th, which should be 64. So there's 64 different ways that these 6 true-false questions can be answered. All right, very nice. Let us move on to example 3 then. And let's see, radio station call letters in the United States consist of either 3 or 4 letters, mostly 4, but there are 3 out there, of which the first must be either K or W. In my understanding, and this might not be 100%, but my understanding is radio stations actually east of the Mississippi River actually begin with the W. I grew up back east, and so all the radio stations I listened to as a kid all started with W. But the ones west of the Mississippi River actually start with K. The one that comes to mind out of Boulder, of course, is KBCO. So again, just I don't know if that's 100% true or not, but I believe that is the case. Okay, anyway, assuming that letters may be repeated, determine the number of radio station call letters possible. So a couple ways we can think about this. It looks like we could figure out the number of possibilities for 3 letters and then look at the number of possibilities for 4 letters as well. So that's what I'm going to write here, and I'm going to shortcut this a little bit, but we're looking for the 3-letter possibilities or 4-letter possibilities, and I'm going to write something after this in just a second. So I'm going to put this off to the side. So either 3 letters or 4 letters. Now when we see the word or with counting, and again we're going to see this when we hit some probability, or means add. So what we're going to do, and think this logically through, if we find all the number of 3-letter possibilities, add them to the number of 4-letter possibilities, then obviously we get the number of total possibilities. So 3 letters or 4 letters, so we're going to put a big plus right in between the two. All right, well, let's create the number of 3-letter possibilities and get this moving along. So it looks like, you know, as I'm thinking about the 3 letters there, it does say the first letter must be either K or W. So there are only 2 possibilities for that first letter, right? It's got to be either K or W. And then the next task essentially would be to look at the second letter. Now it does say letters may be repeated, so you're going to have to actually be careful about some of this stuff, but letters may be repeated. So this can be any letter, 26 letters in the alphabet, so 26 possibilities. And then third letter, how many possibilities are there for that third letter? Well, again, could be any of the 26 letters. So that seems to be how many, and by the way with multiplication, how many 3-letter possibilities we can create. Awesome. Now let's go over to the 4-letter possibilities, and as I look at the individual tasks, kind of breaking it down, I would look at the first letter, knowing that that has to be either K or W, so there are only 2 possibilities there. And then just going through, while the second letter can be any of the 26, I can repeat, of course, so again, the third letter can be and the fourth letter can be. So I'm hoping you kind of see how the individual tasks play out. First letter, second letter, third letter, first letter, second letter, third letter, fourth letter. Cool. Now it could be either 3 letters or 4 letters, so everybody, I'm going to put a big plus in between here, and we should be able to come up with the final answer momentarily. So if you do 2 times 26 times 26 on your calculator, should give us 1352, by the way. And again, you have your calculator, and you can certainly confirm. And then for the 4-letter possibilities, if I do 2 times 26 times 26 times 26, I get 35,152. Excellent. And then, of course, I'm going to add those together. And so I get 36,504 possibilities for 3 or 4 radio station call letters. All right. So you can see we're starting to build up a little bit here. This one had a little bit more to account for. And I've been using this intuitively, but I do want to be a little more formal with it just down below here. So you can see I've been using what are called slot diagrams. Basically just a little slot and deciding how many possibilities there are for that individual task, and then the next individual task, and then the next individual task. So you can see that right here. I just put this down below. So you might want to just kind of box that up, or I don't know, highlight that in some way. That might not be a bad idea. But as I said, without talking about it beforehand, I've been using these anyway, and it's a great way to organize your information there before actually then multiplying it out. So let me just kind of read this, and then we'll go through the last couple examples together. So slot diagrams help organize information before applying the fundamental counting principle. And I put this in bold. Be wary of special conditions that can affect the number of ways we can perform various tasks. So the first thing we need to do is account for the conditions. Alrighty, and we'll see this on the back side of your sheet here. Okay, let's go ahead and get into the next example. Looks like several different variations on it, but again, just keeping the premise straightforward, and then we can kind of go from there. All right, well, example 4. In order to open the teacher's copy room, a person must enter 4 digits from 0 through 9 in order, and how many possibilities are there if repetition is allowed? All right, sounds good. So this is probably the most straightforward approach. And so very simply, the first task would be to enter the first digit, and I don't see any special conditions that we've got to deal with. So I'm thinking about just that first digit. I'm just going to put first underneath. You don't have to do that if you don't want to, but just helps me. And it could be anything from 0 to 9, so there are 10 possibilities. Awesome. And then my next task is to punch in the second digit. And it looks like it can be any one of the 10 digits, 0 through 9, again, because repetition is allowed. And then I go to the third digit, 10 possibilities for that one. And lastly, for the fourth digit, 10 possibilities for that one. And then I'm going to throw a little multiplication symbol right in between. And as you can see, guys, we get 10 to the fourth, and 10 to the fourth is going to be 10,000. So 10,000 possibilities. If there are no conditions whatsoever, repetition is allowed. Perfect. All right, now let's move on to letter B. How many possibilities are there if repetition is not allowed? So if you know the numbers do not repeat, how many possibilities are there now? Obviously, it's going to be less than 10,000, right? Because some of the possibilities that worked here are now not going to work for part B. Well, let's break it down piece by piece. Again, really no special conditions that we've got to deal with first. Your first task is still to punch in that first digit, and I would still argue that there are 10 possibilities. It could still be anything from 0 to 9. So this one is now set. So when I go to punch in the second one, I know that the second one has to be something different than that first one. So the first one is already in. So now that the first one is in, there are only 9 digits left that can be possible. I hope that part makes sense, because this one's already in. Whatever digit that is not available for the second digit. All right, now 2 digits are in. So now I'm going to punch in the third, and how many possibilities are left after I've punched in the first 2, knowing that this one can't be either of those first 2, well, there are only 8 possibilities left. And I'm hoping, that you start to see the pattern here. So for the fourth digit, well, it can't be any of the first 3, so there have to be 7 digits left. Perfect. Now that I've figured out how many possibilities for each individual task, for the entire outcome to occur, I would multiply those together, and I get 10 times 9 times 8 times 7. And if we do that, we bring down the number of possibilities from part A almost by half. So there are 5,040 possibilities. Okay, very good. Now let's throw in another little curveball here if we can. So how many possibilities are there if the first 2 digits are odd and the last 2 digits are even and there is no repetition? All right, so we have some conditions that we specifically have to deal with. So first order of business, of course, is to punch in that first one. So the first one has to be odd. And so I look at my digits 0 through 9, and it has to be either the 1, the 3, the 5, the 7, or the 9. And so there are 5 possibilities for that first digit. So that is a condition that we need to uphold and account for. And now we know that there are 5 possibilities for that first number. Now we know that the second number is also odd, so I've got to punch in the second one. It is an odd number, but since no repetition is allowed, again, just kind of keep my eye on some of the wording here, no repetition is allowed, so whatever digit this was, that's now out of circulation, so there are only 4 odd digits left. Okay, good. Now I've got to punch in the third number, and the third number has to be even. And so it could be either the 0, the 2, the 4, the 6, or the 8. So it seems to be 5 possibilities for that third digit. And then I go on to the fourth one, knowing that that also has to be even. And how many even digits are left? Well, whatever this one is, that's out of circulation, so now there are only 4 left. And so as a result, multiply them together, 5 times 4 times 5 times 4, and looks like that would give us 400. Okay, so obviously you can see the more conditions, the fewer possibilities there are. Okay, and now lastly, let's see. Letter D, how many possibilities are there if all 4 digits are prime and there's no repetition? Okay, so think about the prime values from the digits 0 through 9, by the way. So first one I've got to punch in there, so the first one has to be prime. Okay, and well, let's see, I'll just put this off to the side. 2 is prime. So remember, prime means there are 2 distinct factors, and only 2 distinct factors. So 2, 1 and 2 are the factors of 2. 3 is prime, 1 and 3. 5 is prime, 1 and 5. And 7 is prime, 1 and 7. So out of these digits here, those are the prime numbers, so now we can work our way down pretty nicely. So it looks like the first digit can be any of these 4. So you would say there are 4 possibilities for that first one that we punch in. And let's see, the second one's got to be prime, but different than the first. So now you can start to see that would be 3 possibilities there, 2 possibilities for the third one being prime, and only 1 possibility for that fourth one being prime. Hope that makes pretty decent sense as we get a final answer here of 24. When I multiply them together, I'm going to put my multiplication symbol in between. Looks good. And go with 24 possibilities. Okay, so specific situations, specific conditions that we need to account for. Great. All right, now we get into the last one. And this is a really good one in that we've got to absolutely positively make sure we deal with the condition first. There are going to be some practice problems that are going to be very similar to this, so kind of refocus your attention. So, and I'll try to slow it down a touch just to make sure we're all good on this one. Okay, so a buddy of mine and I play guitar together, and we've got, and by the way, this is a totally contrived problem. It's just a good one to use for the type of problems you're going to see in the practice. But we'll go with 20 songs that we can play together. So while sitting down to practice, so say we decide to just have a 7-song practice, and there are a couple Grateful Dead songs that we want to play, and they work really well kind of playing back to back. So we're going to make sure we get to them consecutively. How many possibilities are there to practice those 7 songs? All right. As I said, contrived, but I like the idea behind the problem itself, so let's go with it. So here's what I'm going to do. And I would encourage you to do this as you start to work on these types of problems independently. We have to be a little careful. I'm going to put 7 spots here for the 7 songs, but it's not how we're going to fill the blanks initially. So 2, 4, 5, 6, and 7. Now that's just to kind of think about 7 songs. There they all are laid out. But in reality, this is going to be my slot diagram down here. And so what we need to do, the first thing we have to do is meet the conditions of the problem. And the condition is specifically make sure they get to 2 Grateful Dead songs which will be played consecutively. So how many ways can that occur first? Then we can start thinking about ways to play the other songs. So my thought, and this is just the way I break it down, is we have to figure out which pair of slots those 2 Grateful Dead songs are going to be in. So for example, if you look at this, I'm going to circle it. We could play those 2 songs here and here, the first and second. We could play them second or third, third and fourth, or fourth and fifth, or fifth and sixth, or sixth and seventh. So this is how I would kind of write it, and I have this on my paper. I'm going to put it on the board. This is the number of pairs of spots for the Grateful Dead songs. Because we have to meet that condition first. And so just our first order of business is like, all right, which pair of slots would we put the Grateful Dead songs in? And as I counted them up here, 1, 2, 3, 4, 5, and 6. So there are 6 possible pairs that the Grateful Dead songs can sit in. All right, so that's our first order of business. Now, once this 6 is written, what you want to do is actually pick any one and just kind of highlight it. So I'm just going to pick this, totally arbitrary, and be like, all right, now I figured out which pair. So now we've got to get those Grateful Dead songs in that particular pair of slots. So for example, I need to figure out how many possibilities there are for this particular spot right here. So here's how I wrote it in my slot. So number of ways the first Grateful Dead song can be played. So I just shortchanged that in my writing here, but basically I look at this slot now and I know that one of the 2 Grateful Dead songs has to be in that particular slot. So there are only 2 possibilities for that particular slot. So what I do is I write my 2, and I'm going to go ahead and put a little X there because now that's taken care of. Okay, so it could have either been the first Grateful Dead song or the second Grateful Dead song. Again, I've got 2 possibilities. Either one can be played there. It doesn't say one has to come before or after the other. It just says they're going to be played consecutively. All right, perfect. Now, I go to the next and I say, all right, well, all well and good. I know how many possibilities there were for that one. How many possibilities are there for that slot? So this would be number of ways the second Grateful Dead song can be played. Now this is not totally mandatory because you know there's only one Grateful Dead song left, right? We had 2. I put 1 here, so that means there's only one possibility for that one right there. So you kind of see as I use this as a visual tool, what I'm really doing though is figuring out how many ways I can satisfy this condition and then this and then this, and I work my way down each task independently. Now if you look at this stage, and this is why I like putting the X's there, I hope you would agree with me, but all right, now we figured out the Grateful Dead songs are in. We know where they're going to be played. We know how many ways that they can be played. Now we just go on to the next. So there are no more conditions to deal with. So my next task is just to figure out the number of ways that the next song can be played. All right, now since there are no more real conditions left, I just figure out how many songs overall are left to put in my next spot there. And well, let's see. Obviously, we figured out that the 2 Grateful Dead songs are out of circulation at this point. So what that means is we've got 18 left from the 20. Perfect. And as I write that, it's all well and good. It's like now I've got 3 songs accounted for, so I can almost just X out another one of those slots for the songs. And then I think about the number of ways I can do the next song. So, all right, well, now I go to the next song. How many ways can that one be played? Well, there are 17 songs left after 3 are now out of circulation. So once I write that 17, all right, cool, that's filled in. And then I go to the next one. How many ways can I fill in that next slot? Well, looks like there's 16 songs available. And then when I write that 16, I just kind of X that out there. And let's keep it going. Number of ways for the next song to be played. Well, it looks like there are 15 songs left for that next one. And I'm hoping you kind of see how this is going to play out. Finally, 14 for that last one. All right, so the key is getting the condition taken care of first, and then once that condition is satisfied and you've figured out how many ways to work through that condition, then we can just fill in piece by piece by piece with whatever's left. Now, as I've said, once we have figured out the ways to perform each individual task, then I multiply all those together. And so with this scenario, with my friend and I playing some songs together, how many possible 7-song sets can we play, knowing that those 2 dead songs had to be played back to back? Well, if you answer this right here, it looks like I ran out of room a little bit, so I'm just going to come down here and write my answer. If you multiply all that together, I get 12,337,920. All right, so tried to be as visual as possible and try to walk you through the mindset here. As I said, you're going to see some of these that deal with satisfying the condition first, then playing out the remaining tasks after. All right, I think I'll leave it at that. If you'd like some help as you go through some of these practice problems, I am more than happy to have that dialogue with you and kind of walk you through the mindset to be successful with these. All right, everybody, thanks so much.